Alright, what can I do? What we got? What we got? Sorry. Yeah. 6. Okay. So I'm gonna do this twice. So I'm gonna do it the same way I taught you, and then I'm gonna show you that U substitution way. Which I'll talk. Let me just do it the regular way first, and then I'm gonna show you the U substitution way, which is like probably what you learned in college. Remember we talked about that yesterday? Yeah. So I'll do it the old way, and then I'll show you the new way with it. So the old way, which is totally fine. There's not a problem with it. It's just when you get to college, it'll be a little adjustment. This is your big guy. This is your little guy. And so I want to find out what little guy prime is and see if I have it over here, if I get to adjust. So derivative of cotangent would be negative cosecant squared of negative 3x times negative 3. You got to do the chain rule. So it's really 3 cosecant squared negative 3x. Well, we have 12 cosecant squared negative 3x. So we'll have to multiply this by to turn it into that. Be 1/4. And then that is little guy prime, which makes it disappear. We're going to do 4 out there. And then I can integrate the big guy. Jasper, you good so far? Are you good? Okay. So add 1 to the power, which will make it 3/2. Multiply by the reciprocal, which is 2/3, so we'll have an 8/3 out there. Leave the little guy alone. And then put your plus C. Alright? Anybody else? Jasper or anybody? Questions there? Alright, let me try this U substitution thing and see if that makes any sense to you, or if you like it or don't like it. So it's similar. We're going to find the little guy first. We've been writing down like L equals. What you're going to do is find the little guy, and you're going to call it U. So it's called U substitution. We've almost been doing like L substitution, like we just call it a different thing. And what we're going to do is rewrite this problem so there's not any X's in it anymore. We're going to rewrite it so it's all U's, which will make it a simpler problem to do. We'll integrate it, and then we'll put the X's back in. So we're like packing it in to make the problem look nicer and easier. Integrate it because it's a lot easier to integrate what we'll get to, and put it back. So the first thing we're going to find, just like we did with like L and L prime, is du. So du is the derivative of u. So we found our little guy, we're doing little guy prime. This is just, we found u, now we're going to find du. So the derivative of cotan, negative cosecant squared, negative 3x times negative 3, times dx, which will matter in a second. So then that's positive 3. And the dx, you don't technically understand what's there for yet. Just trust me. It's not a fair enough thing at this point. It's coming. Like, when we get to the second version of integrals, you'll know what it's for. But right now, it just goes there. So now when we go to write our new integral, this is going to get replaced with u. What we need to do is match up this and flat stuff. I should use a different color. So this and this, we want to make this. We want to match these two up, but I match it up in the opposite order of what we normally do. I want to change this to make it 12. So what would I have to multiply by here? By 4. But then I multiply this side by that also. So what I have now is 4 times du equals 12 cosecant squared negative 3x times dx. It's very colorful. So now when I go to rewrite the problem, instead of putting 12 cosecant squared negative 3x times dx, I can put 4 times du. You see how those match up? So up here I have this 12 cosecant squared blah blah blah, and I have dx. Down here I have that same thing, but I've determined that it's actually the same as 4 times du. So I'm going to put 4, I'm going to put the du at the ends, and then this is u. That's the hard part, like plugging those in and kind of setting. Now we're just going to integrate for u, which is a heck of a lot easier than integrating the nonsense we had before. But getting it set up is a different story. It's not necessarily easy. So the questions I can answer on it.
Is Rebecca here?
Yes.
This is what?
As I'm going through, I'm looking at your face, and I'm like kind of questioning whether I should be showing you this. Yes, I should be, or no, you shouldn't. If you want to stop listening, you're welcome to. Like, I'm not going to be offended if you're like, this is stupid. I'm not gonna... What I would do from here is integrate that. So what's the integral of 4u? Add 1 to the power. What's the integral of 4x? Yeah, that's just a variable. So it's 2u squared, right? Well, what's u? Oh wait, this was to the 1/2. I forgot that. I skipped the whole 1/2 part. So what's the integral of 4u to the 1/2? U to the 3/2 multiplied by the reciprocal. So 8/3 u to the 3/2. But then what's u? Is that cosine of negative 3x. And then plus c. It's really similar to what we've been doing. It probably going through it, I'm like, okay, this feels more complicated than I actually kind of remember. So I'll do a couple more. Like when you guys ask questions, I'll do one the old way, one the new way. I just basically want to expose you to it so you can decide. And so when you get to college, you're not like, what is this new stuff? I've never heard of this. You know, I have like conflicting goals. Most of my job is to get you like to pass the AP test, but I'm also supposed to pay for college. It's kind of different sometimes. So I try to do both the best I can. Questions I can answer on this one?
Why use u? It just seems like more trouble than it's worth with at least the integrals we're taking now.
So that's part of it, is it because at least the ones we're taking down, so when they get harder this year.
It'll be easier.
Yeah. Like if you're doing, I don't know, how many of you guys write down like the L and L prime? If you're doing that, you're basically doing U substitution. I don't know if I'd really even change it, but that's like the main part of the process. It's supposed to help you organize. Like, here's my little guy. Here's the dribble little guy. But we essentially do it anyways, just in our own terminology. Yeah, and so if you're asking me, I don't necessarily think there is a benefit, except when you go to college, they're not going to talk about big guy little. So I don't want you to be like blown away. You know what I mean?
Okay. But they won't expect it, like if they ask for work, it won't matter if you use U substitution or not in theory.
There are certain problems you need U substitution for. Like the big guy little guy won't work. So you're going to have to learn eventually. It just doesn't have to be right now.
Here's the part where I would ask what would a problem that needs U substitution look like, but then you give me a
Basically, yeah. So if I give you something like this, what's the little guy here? Bx minus 4. The derivative of that is 1. I can't multiply 1 by a constant and turn it into x. So my big guy, little guy method just failed. So what you would do here is say u equals x minus 4, and then you can say x equals u plus 4. So you can put a u plus 4 here, and a u here, and do the problem out. But that's not on the AP test, so I'm not going to worry about it. Spend any more time with that. But at least I didn't just say wait till cup 2, right?
True. I appreciate that.
All right. What else? What else can I do? Yeah.
16.
60. Jeez. All right. So I need some help. Like, can you see what the big guy is right away, or not? Is that bad?
No idea.
Okay. So that's what I need. That's what I need help with. So let's start let's play because I'm not sure where the struggle is. So let's play the game and try it. Like if I make cos my big guy, this would be L. What would L prime be? -2. Can I multiply -2 by a constant and turn it into that crap? No. So cosine can't be my big guy. What if I made sec my big guy? That would make this little guy prime. What's the derivative or little guy? What's little guy prime then? Cosine -2x times -2. Can I multiply what we just said by a constant and turn it into cos tan? Not gonna work. Same thing here. If I make tan my big guy, sine would have to be the little guy, and that's just not gonna work. But what would work is the big guy. It might be easier. What do you think the little guy is? That might be easier to pick out. The sine -2x is your little guy. Because it's like written twice, that kind of gives you a clue. Like we're taking some stuff of the sine -2x. That'll make sec tan your big guy. And you know how to integrate sec tan, right? You sec. So L would be sine of -2x. L prime would be cosine of -2x times -2. So once you see the big guy, it's not bad, right? It's just you couldn't pick it out. Yes, no? Okay.
It helps if you add parentheses.
Yeah, I hate how they don't put parentheses there. So I need this to be -2. Right now it's -4. I'll multiply by half, which will then make this little guy prime. Cancels out. Multiply that by 2. And then you integrate the big guy. So what's the integral of sec tan? Sec. You leave the little guy alone, or this would be like the u if you were doing the u substitution method. And then plus c.
What would be the U?
I'm going to do it in a second.
Oh, okay.
Any questions on this method? All right, so for the u method, is it okay if I don't rewrite it? I just do this. U is the little guy. So u is the little, what we're calling L and what they call u are the same thing. So the little guy is the u, so you would say u equals sine of -2x, which means the derivative of that would be cosine of -2x times -2. So I can kind of start rewriting it already. What I'm going to have for this part of the problem would be sec u tan u. Does that make sense? And then what I need to do is match up. So you almost want to take this dx and instead of writing it over there, imagine it's here. And I want to be able to match up this and this guy here. So we're matching the opposite direction. When we do it our way, I'm making this match up with that. When we do it this way, we're making this match up with that. So that's kind of the main difference. So what do I need to put here? Or what do I need this to be? I need it to be a -4, so I'll double everything. So 2 du would equal -4 cos -2x. So now instead of putting the -4 cos -2x, what can I put down here? 2 du. And the du I'm just throw back at the ends because it doesn't really affect the way I do the problem. It's just kind of there. Did that get a little better the second time through? Those of you that are watching. Some of you were like intentionally looking away. So then you just integrate. So what's the integral of sec 10? You sec. Then you put the u back in. The u was sine of -2x. How many feel like you have somewhat of an understanding of that u method? Right. How about like it better? We don't get that complex in here, so it doesn't really matter. But you will next. That's the thing. I don't want to feel like I'm not preparing you. These little bits next year, you know.
Can we do this, the U?
Absolutely.
On the compass?
Yeah. Yeah. Absolutely. Yeah. Yep. You way or the old way? Okay. So the old way would well, so I guess let's pick out the big guy and the little guy. I think it might be easier to start with like what's the little guy. So like this sec x is being signed, like something's being done to it. So there's a good chance it's the little guy because there's something being done to it. You know what I mean by that? So let's just check that first. If sec is the little guy, what's the derivative of sec? Sec 10. And so that tells me I'm on the right path there. So we start with that. Little guy is sec of x. Little guy prime would be sec x tan x. And so I need this to be sec x tan x. Two ways I can do it. What can I multiply this by? -1/3. But then I'd balance that out by putting one out here. A -3. So couldn't I also just take that -3 and like slide it out? Like click on it, drag, you know what I mean? So you can do it either way. Like do that and then flip it, or click and drag it out there. Either way, this is going to go away. And then your job is to integrate the big guy. So what's the integral of a positive sine? Negative cosine, right? So then a -3 would be +3 cosine sec of x. How's that, Jasper? Would anybody like me to do it that you would? Okay. I'm going to rewrite it because that's kind of a mess. So if we're doing it the u way, what's u? Secant. Du would be secant x tan x times dx, but that part just kind of, you don't really need to worry about it because the dx are just going to match every time. And then we're flip-flopping what we match. So now I want this to equal this. So what do I have to multiply this entire equation by? -3. So it'll be -3 times du equals -3 times sec x tan x. Now rewrite. So instead of -3 sec x tan x, what am I putting? Oops. -3 du. But the du I'm going to put like way at the back because it doesn't really matter. And then I have sine of u. Right? Because this is what I call u. So integrate this. What's the integral of positive sine? Negative cos. So now I get negative 3 cosine of u, or positive 3 cosine of u. And I just put the u back. Feels funny saying like cosine of u, secant of u. Like it's personal, like I'm taking the sine. I'm just curious, is the u getting better or worse or not? Give me like thumbs for the u. I'm not even paying attention, I have no idea, I don't care. I'm not offended by that. That's fine. I like it, I get it. I might use it, I don't know, I'm still deciding. Just don't flip me up. Alright. What were you gonna ask?
Number 9.
So I'm going to rewrite it just by bringing that up first. Is that okay? Oh, no. I should go through that. That's one of the mistakes I saw yesterday. Okay, so what I saw a lot of people doing yesterday, and it's not wrong, it's just you have an extra step to do and you have to realize what the step is. Is you started off with this, so you kept the part on top and you brought this entire chunk up and made it to the negative first. Then I got like 2 or 3 people were like, hey, I'm stuck. I brought it up, now what do I do? 2 things you could do to fix that. One is, remember, this is really like cosine of 4x to the third. Like this 3 is technically written like out here. And so you have a power to a power. So what do you do with power to a power? You multiply them together. So what I'll end up with is just this to the negative third on top. Well, couldn't I have shortcutted that a little bit? If I had the third power on the bottom and I bring it up, it's going to be the negative. And there's nothing wrong with the 2 steps. I think you guys were just so used to the negative 1 power because we're doing all that over and over again. You kind of forgot that. But let's just start with, let's say we're at negative 3. Right. So, what's the big guy? So we need different answers. So let's try. Let's start with this. What's the little guy? That's probably easy. The cosecant of 4x. So if that's the little guy, what's the big guy? The negative 3. So this is what's happening to the little guy, which makes it the big guy. So then what's the derivative of cosecant? Negative cosecant cotangent. So it fits that way. If you try other big guys, it won't fit. So L equals cosecant of 4x. So L prime equals negative cosecant of 4x. Cotangent of 4x. That's 4. And so I have negative 12, but I'm supposed to have negative 4. So I'm going to multiply by 1/3. 3 on the outside, which will make all of that crap. That's the nice thing about this. You get this giant problem, and you get to just cross out most of it. Good so far? And then you integrate the big guy. We haven't done that in a while because we've been doing like E's and LNs and stuff. But how do I integrate a power? Add 1, multiply by the reciprocal. So negative 3 plus 1 is negative 2, remember. Reciprocal is negative 1/2. So I'll have negative 3 halves, and then plus C. Is that right?
Yeah.
Didn't you ask that?
Yeah.
You're processing still? Sorry.
Yes.
You're like on this one, you just like wandered in.
Yeah.
I'm glad you got the artifact. But she could like not.
Was negative, like the negative 12. I thought it was negative 12 there.
It was.
So then what do you do multiply by negative?
That's negative over here too.
It's a negative 4 or negative. Oh, okay.
Good. Then you're also okay. Yeah. Yeah. So again, it might be easier to start with what's the little guy. So like this whole thing is being raised to the negative 4th power. So it makes sense to me to start with, let's see if this is the little guy and this is the big guy. Well, if I make this the little guy, what's the derivative of e to the 4x? E to the 4x times 4, right? And out here I've got e to the 4x times 16. So I can work with that. So this is my big. My little is e to the 4x plus 5. Wait, that plus 5 is down here, right? In the problem?
Yeah.
It's not like the one here. Okay, thank you. So then the derivative would be e to the 4x times 4, because you got the chain rule piece. Well, I have e to the 4x times 16. So I need to multiply this by 1/4, because that'll make that 4, which will make this go away. And if I put a 1/4 on the inside, I got to put a 4 on the outside. And then the big guy's a power again. So add 1, multiply by the reciprocal. So I'm going to have to the negative 3rd power. The reciprocal of that is negative 1/3 times the 4 that was already out there. Will give me negative 4/3. And then the little guy stays the same. Alright? Sure. Okay. Yeah.
Number 7.
Yep. Is this one good? Am I still right or anything? So let's start with the little guy again. What's the little guy? X to the 4th minus 5? Is that what you're saying? You just pointed, but there's kind of a bunch of talking there. So that would make cotan the big guy, right? So then what's the derivative of x to the 4th? This one actually is set up. If you see the big guy, little guy, okay, it's a little bit shorter. So this is your little guy, which makes cotan your big guy. So what's the derivative, like what's L prime in this case? 4x to the 3rd, so I don't actually have an adjustment to make, which maybe threw you off, because like almost all of them do. But I could just do the problem. Oh, there's the issue. What's the integral of cotan? That's what I'm saying. So the integral of cotan is one you're supposed to memorize. Or, I can kind of go off to the side and remember that cotan is what over what? Cosine over sine. Which is really like cosine times sine to the negative 1st, right? So this is like I'm doing like a separate thing. I'm going to go back here in a second. So if I'm just doing this one, big guy, little guy, what's the derivative of sine? Cos. So I'm going to integrate the big guy. Add 1 to the power, I get 0, multiply that way, that doesn't work. So what do we use instead? Natural log. So this is the natural log of the absolute value of sine of x. Plus c. So the integral of cotan is the natural log of sine of x plus c. So when I go to integrate cotan, it's going to, I don't need that anymore. It's going to be the natural log of sine of, not x, but x to the 4th minus 5 plus c. So that's why that was tough, because that's a cotan one. Tan. So the same idea. Tan and cotan, remember, you can memorize those, or you can just kind of work through on the side every time. So So Richard was at the issue that Cotan part? Yeah, that's tough. Just because we just heard it like yesterday. Yeah.
Can you do number 8?
Is anybody still writing this? Looks like you're still writing. You're good? Okay. I was debating whether I should give an extra day for this or not. Like today. I'm glad we did because it seems like there's a lot of questions. So it's got that seek 5 4x. Remember that really means like this 5 here makes a lot more sense if you write it outside like that. So the 5 in the middle here, if you transport it to the outside, it's a lot easier to see. Okay, but now that's the big guy. Sec of 4x is the little guy. So L equals sec of 4x. L prime would be sec of 4x tan of 4x times 4. Jack, you with me? But I got an 8. I need it to be a 4. So I'll multiply by half, which will make all of that disappear. Makes the problem look a lot less intimidating. Now that's a 2 out there. And then the big guy is my 5th power, so if I add 1 and multiply by the reciprocal, add 1 will give me 6. Multiply by the reciprocal will give me 1/6. Times 2 is 2/6. Or reduce it to 1/3 if you want. Or no, doesn't matter. And there's your answer. Is that good? We did end up doing almost all. Is it getting easier? Is it getting better? I got the same amount of questions yesterday, but I feel like you understand it a little more. Right or wrong? Give me thumbs. Not the U part, but just like the big guy, little guy part. Okay. Are there more? I didn't stop. If there's more, I'll go. Let me see how you do. Missing 2 days. Come back to this. You alright? Alright. You want me to start? What's your time? Is it okay if I just rewrite it right away?
Yes. That's usually what I do.
Okay. So that's my little guy, right? So it's being like something being done to it. That's my big guy. So little guy equals e to the 4x minus 1. Little guy prime would be e to the 4x times 4. So I'm close. What's something I have to change? The negative sign. So I can do, I get to that situation where I can either, like if I put a negative in here to cancel it, what am I going to have to put out here? A negative. So I can also do that like click and drag thing. You can do it either way. You're going to end up with a negative out there, and that stuff is going to go away. And then my job is to integrate the big guy. So I add 1 to the power, I get 0, multiply by the reciprocal of 0. That doesn't work. Oh yeah, that's natural logs. So I'm not taking the natural log of the negative, but it's a negative version of whatever the ln was. So that's legal. You can't take the natural log of negative 6.
I thought that's what I said. Sorry.
Oh, okay. I thought you were asking. No, I'm sorry.
Like Naomi pointed out yesterday, if I'm talking to myself, or if I'm talking to
Sometimes
someone
it's
else,
tough to tell.
Okay, but I tend to give people's attention first.
Okay.
If I'm talking to myself, I just start talking.
Fair enough. Alright, you guys are starting to like drift off of talking, which I'm late. I've been doing problems for 40 minutes. Knock goes over your dance. Things are changing. So let me ask, if you have more questions, I'll walk around and, I mean, I'm not mad. It's hard to pay attention to someone just do backgrounds for 40 minutes. It's a long time. Well, I know these, if you have more questions, I'll come around and answer them individually. Just one more day of practice. Tomorrow we'll be moving on. There's two kinds of integrals. Some people are starting to ask when the gateway is. So we've done one kind. There's all other kinds to get through. We've done indefinite integrals. We need to do definite integrals. It's a little more annoying. It's not hard. So it's after you get the integral, you have to plug in a bunch of stuff. You've learned the hard part. You haven't learned the more annoying one.
So it's plugging things in for us.
Yeah. Shut up. It's a start. What are you doing?
What's up? What are you doing?